Good evening and thank you for joining me. We have a potentially dangerous situation unfolding for Tuesday evening and Tuesday night here in Northeast Louisiana, central and eastern Arkansas, west central Tennessee, and west central Mississippi, as we're going to have a severe weather outbreak. There is a hatched area for wind and tornadoes here in north central Louisiana, east central Arkansas, west central Mississippi, and Tennessee. This region is under the gun for damaging winds and potentially violent tornadoes. Hail will also be possible, but the air is going to be very tropical and moist, so hail is not going to be a big threat. If there is going to be any hail, it will be more on the western periphery. But there's also going to be a squall line that's going to develop and move southeastward. But ahead of that squall line, there is a potential for discrete supercells that could form along the Gulf plume. There's going to be a big plume of moisture coming up with showers, and any of these showers can run into this unstable air and quickly become thunderstorms and become supercells. So here's what the NAM is saying right now for this event. So as we go into late Tuesday morning, 12Z around 6 a.m., there's going to be some showers, light showers forming, which will mean the air is going to be very cloudy. It's going to be very cloudy. But as we work our way into the afternoon, there's already some convection here. They're not showing supercells, but this is still kind of late right now. This is still pretty early in the forecast. So these showers could potentially become supercellular. Here is what the HRRR is saying for the outbreak for Tuesday. So going to around 16Z, this is around 11 a.m. in the morning. This is about 1 p.m. 2, 3, 4, 5, 6, 7. So already we're having cells with the appearance of a supercell. Look at that. We're having supercell appearance storms right here. You can actually see that storm right there. Looks like a supercell. We're also having some tracks. And this is pretty late in the forecast, so a lot can change. But what they're showing is it's going to be a lot of showers, so the air is going, it's going to be very cloudy. However, your mid-level lapse rates are going to be very impressive. Looking at your CAPE, your convective available potential energy, it is going to be very high. I mean, look at these CAPE values approaching and even exceeding 3,000 in isolated pockets. You're going to have CAPE between 2,500 and 3,000. So that's very high CAPE values. And when you're going to be looking at surface temperatures, they're probably going to be in the mid to upper 70s. But still, you're going to have very high dew points approaching 70 and even low 70s. I mean, look at these dew point values. In the low 70s, you're definitely going to have a lot of convection. You know, with your CAPE values being over 3,000 in some places, dew points in the low 70s, that's very impressive. But then you also need to look at lapse rates too. But they're not showing lapse rates, but looking at 3-kilometer helicity, which is showing how much spin there is in the atmosphere, this is not good. They're showing an area of elevated spin, which means some tornadoes are likely, especially northeastern Louisiana. 1-kilometer helicity, again, elevate areas of increased spin and vorticity. Even here in northeast Mississippi, here in western Tennessee, this is looking really bad. Looking at simulated reflectivity around this area of increased spin, look at that. Look at all these supercells. These are supercells, guys. All of these storms here could become easily supercellular. We could have some tornadoes here in northeast Louisiana, western Mississippi. So this is definitely very high risk here for tornadic storms. Maybe not a lot of hail, but definitely tornadic storms, because you're going to have very high wind shear. Look at these southerly winds coming in, but your storm motion is coming from the southwest. So you're definitely going to have wind shear. Absolutely. In fact, looking at supercell composite right now, I mean, here I can't check the sounding, but that's some pretty high supercell composite parameters. And then looking at significant tornado parameters, Look how high it is in northeast Louisiana. You see that little red area? I mean, that little blue area? I mean, that's a supercell right there, too. Let's look at simulated reflectivity. Right where you're having that area of blue, right there, boom, there's a supercell right there. So that could be a tornado on the ground. Even though it's not showing rotation, like they're not showing the updraft velocity swath, that is a supercell right there. They could actually see the structure of the storm, of that cell. That's a supercell. So we're having a threat of tornadoes. But now we're going to change gears and look at the NAM itself. Look again, supercell composite. So let's look at the Southern Great Plains, about hour 21Z. This is about 10 p.m. in the evening. So supercell composite parameter showing around 10. That's pretty elevated, but again, that's some pretty intense lapse rates and pretty high chance of tornadoes. They're even saying supercell parameters are pretty high. Look at that slinky showing 73 degrees and showing at least a 60% chance of EF4 plus tornadoes if one were to develop. So this outbreak is definitely significant. Has a potential to become significant, especially if supercells form. I mean, we could be having several tornadoes on the ground. This definitely looks scary. It looked pretty good this morning, like maybe it wasn't going to be so bad, but now it looks bad again. So let's look at supercell significant tornado parameters. Look at northeast out Mississippi there. That is very scary. That's scary. That's really, really scary. I mean, that's just the operational NAM, but still, that is not good. And look at that, just a few hundred, just not even 1,000 feet off the ground, and you're starting to have that jet, low-level jet right there, that nocturnal jet. So right there, southerly winds, not too strong, but then just a few hundred feet up. You know, this is about 5,000 feet up, so about 925. So this is only not even 2,000 feet up, and already low-level jet right here. It's really bad. So you're not even a kilometer up and already having really strong winds. Then they weaken off a little bit, and then they strengthen again. So again, not good. And very moist near the ground, and then drying up as you go up. So if you have a supercell that's going all the way up to here, you're having middle level dry air, especially from about 700 millibars up. You know, great opportunities for rear flank downdrafts, because you know this will cause significant cooling as the dew point and temperature try to balance each other out. So that can cause some really strong RFD winds on the backside of the supercell, which will enhance tornado development. So first of all, you got wind shear. Second of all, you have instability, and then also you have mid-level dry air and surface moisture. So all things are looking bad right now. And I do see a little bit of an inversion with the dry adiabats going over the moist, but with the surface temperatures, the dry adiabats still rising faster than. So that's a little bit of an inversion, just a little bit. But then it's unstable all the way through. So you could have some mid-level development, like storm bases being maybe a little bit higher up, but still they can work their way down to the surface. You're definitely having wind shear. And plus this is after dark after all, so let's go about 21Z here. And look at these parameters here. Oh, almost had a little inversion there, but again, still pretty unstable. And look at this, showing PDS tornado, which means that if supercells were to develop, they will definitely produce strong tornadoes. This is not good. You never want to see this. I mean, even though this is lower, but the potential is there for violent tornadoes. So now we're going to change gears, and we're going to talk about the weather in terms of snowfall. So let's look at the North Atlantic oscillation. Models are showing it going down to about -1.5 to near -2, which is very low. I mean, this This supports major blocking from Greenland. I mean, even here is pretty impressive, but being down here, I haven't seen the NAO this negative in winter in several years. Actually, in a very long time. The Arctic oscillation, again, they're all over the place, but all the models are mostly saying it's going to be negative. And the PNA, which right now is negative, is going to become neutral. Like we were neutral, now we're negative, and now we're going back up. Normally when the PNA is negative, the NAO and AO are positive, but it's different now because we're in a La Nina. So as this goes up, we have the potential for a pretty significant snowstorm once this becomes positive. If this goes positive and the NAO and AO stay negative, major snowstorms could form if we were even neutral. Even if we go near, if we're in this position and AO and NAO negative, the Northeast can see a pretty significant snowstorm. So let's look at the models right now. We're looking at the GFS. And the forecast is showing that we're starting to have some cold outbreaks. The 18Z run has been showing some cold air trying to come into the Northeast and the northern part of the country. You see how this is backing up? See how this storm backed its way up? That's because of your negative NAO. And then look what's happening. This rotates back down, and look what starts happening. You start getting this big trough over the Northeast. This is a negative NAO right here. But they're not predicting a snowstorm from this. They're not. In fact, this whole event will not really have much precipitation with it. In fact, it might even be warm because, I mean, you could get a coastal storm to form with this. Like this scenario would be most likely when you would get a coastal system to form. But when you go down to 700 millibars, here's what I'm seeing. Here's that upper level low, that polar vortex. A piece of it comes down. And here you're getting a coastal low trying to form. You see that little, just trying to form in that very cold air. But going down to 850, if it does form, it'll probably be off the coast. See? It's trying to form further east. Because that's what normally happens. If you have a upper level low here, any storm would usually form where you're having the jet streak. This could potentially go up the coast and create a snowstorm. That's what I'm saying. By the middle of December, we have the potential for some pretty major storms. And you're having a high here, so this could just end up going up the coast. Because again, see this this low pressure system here, right? See this blocking pattern that's starting to develop? This could try to form a cutoff low, and any storm system could end up trying to go up the coast or even northeast. I mean, it still is remaining to be seen. But you've seen this ridge here, right? This is your neutral or slightly negative PNA. So right now the PNA is becoming negative, which is why we're seeing this trough here on the west coast. That's why we're having some ridging on the east. But your NAO is going to go negative. So you're still having some warm air coming in. But as that PNA becomes positive, the full effect of the NAO and AO is going to start to become known. Yep, that's it becoming neutral to positive. And then so let's look at the GFS now, or the GEFS. Again, we're looking at the 18Z run. Looks like our biggest chance of getting a snowstorm will be between December 7th and the 15th. And looking at precipitation between the 8th and the 15th, a little bit, it's showing a little bit of snow. And some will snow Accumulation not a lot, but showing some. So there's definitely going to be some snow potential. I mean, look at the Canadian Shield, big snows here. So that could set the stage for high pressure systems to build in maybe towards the end of December because it's going to be so cold up here. And that'll allow storms to be further south. So right now what we're seeing is there's going to be this blocking that's going to develop in Greenland. And you're going to start to have a ridge building in Alaska. But then that ridge is going to weaken. So yeah, basically it's the PNA. The PNA is going to be negative, which is unusual for La Nina, or it's actually more typical of a La Nina. So looking at the world, let's look at, let's look at 850 millibar temps. That is definitely a negative NAO. I mean, see how this is going northwest and how this is going like this? During a negative NAO, this would normally be over here. But as the planet warms, the jet stream is pulling further north. Yep. So that's why we're not getting that much cold air in now. Jet stream's starting to change. Also, it's kind of early in the season as well. Normally, the coldest weather doesn't form until January, February, late December at least. So, North America, 500. So, as we continue to look, you're still trying to get cold blasts here. So here's your positive PNA or neutral to PNA. Here's your negative NAO. And the AO is definitely negative. This looks like a typical La Nina, actually. This really does. But the difference was in 95, 94, 95, 96, 2010, 2011, you had a positive PNA. But right now we're not. I mean, that's the difference. The PNA is basically what is determining whether we're going to get cold air here or not. If the PNA stays negative, then we're not going to get any snow. If we're going to look at the PNA, so let's look at the PNA and compare years. So we're going to look at the PNA right now. So there we go. This is what I wanted to see. Okay. So let's go to 95. It's about November 27th, right? The PNA was negative. So we were dealing with the same thing, but then around January is where, look what happened with the PNA right in the middle of December. It flipped positive late December, and it stayed positive despite the La Nina that we had right until the storm hit. And look, PNA went from positive, slightly negative. That's when the storm hit. 2010, late December 2010. If anyone remember how crazy that year was, 2010, 2011, we had a crazy amount of snow, even though we were in a La Nina. Again, the PNA, believe it or not, was actually negative. We had a negative PNA. See, it went from very negative, like -2, -1, it went from -2.1, and then it jumped right around the time we had the storm to about a neutral. And then January was very stormy, if anyone remembers. January and February of 2011 was very stormy. Again, you were dominated with a positive PNA. And the NAO was very negative. So let's go down to 2019 to 95 again. And look at the NAO. You had a negative NAO when the blizzard hit. Right around this time, you had a very negative NAO that developed. The NAO around this time was very negative. It was about 0.9. It wasn't neutral. So we're in a neutral. We're actually positive right now. And then we dropped, right? 2010. Remember, the PNA was negative most of the winter. Well, at least in December. And look at the NAO. It was negative despite the the PNA being negative. So you also had a negative NAO as well. Pretty negative, about -1.4, -1.5. And then when the storm hit, it continued being negative. And it continued being negative for most of the winter except January around this time. But then it went negative and then neutral again. And the AO was definitely negative. But the important thing to realize is that the PNA, while it was negative, it flipped positive, and you had a negative NAO. So maybe, just maybe, we could get a storm, because from what this is telling us is that you had a negative PNA, you had a negative NAO. But one more thing we didn't look at is the Arctic oscillation. We did not look at the AO for that day, for 2010. Because the PNA was negative, if you remember. Let's go down to December, around the same time. Wow, the AO was very negative. We were like -3, -4 around this time. But then when the storm hit around, look at that, -5. We were, wow, that was a basically, the AO was very negative. Like, we were very negative territory. While we're negative right now, it's basically like, it's not that negative. In fact, if we look right now, this is January. Okay. But if we're going to look at the AO right now, we are pretty neutral right now. We've been in neutral territory for a while. But the models are saying that the AO is going to go negative. I mean, look at this. Because the AO is positive for so long, a lot of that Arctic air is trapped. And then look at it as it just collapses. I mean, we might not go that low, but if you look at the majority of the models, look what they do here. There's a huge convergence right around here. -2. And then look at that. And then some of them go up, but some of them continue to go down to near -3. I mean, yeah, past -3 to near -4. So this is what we need to follow. You see this big convergence right here? In fact, this is very concerning for Arctic ice. So I'm going to wait until tomorrow to see if anything changes, because we could just, kind of do something like this, or we could very well just go down to very negative territories And that would mean a lot of cold air coming into the US, a lot of cold air and a lot of snowstorms. This, if things go down here, it will get very interesting for the East Coast and the Northeast, the East Coast, Northeast, and the Great Lakes region. It's going to get very intense with lake effect. Wow, it's because it's going to get really cold. A negative AO, depends on how negative it gets, could bring down the polar vortex right over the U.S. and storm after storm could go up the East Coast. So the potential for that exists. We're having a major pattern change that's going to happen over the next few weeks, and it remains to be seen whether this is going to bring major snowstorms to the East Coast or inland runners. Because when you're having a negative AO, it's usually like this. So you could have blocking with cold air or just a very cold flow with not much precip. So it will remain to be seen whether we're going to get a lot of precip or not so much. But things are getting very interesting right now. And I'm still monitoring the severe threat for Tuesday. Things are looking very interesting right now, looking into the future. I mean, things are definitely looking interesting now. Just looking at the model before I go. Anyway, yep, look at that. Clipper system. Yep, this is the type of tracks we were having before the big snowstorm on December 27th. Things are definitely looking like that. Negative NAO, negative AO, and a negative NAO. And a negative PNA then becoming positive. I mean, this could very well mean potential major storm. I mean, this storm could end up being further north or further south. Depends on how negative the AO gets. Anyway, thank you for watching, and I'll see you guys later, as I'm still going to make another video in the morning.